So if you think back to the late 1800s, right, electricity was basically just a parlor trick.
Oh, yeah. Pure spectacle.
Right,
Mm.
like people would put on their best clothes and go out to these grand ticketed exhibitions just to stare at a glowing glass bulb. I mean, it was magic to them.
Yeah, but that wasn't the actual revolution.
Exactly. The actual revolution didn't happen while everyone was staring at the bulb. It happened a few decades later when the bulb became boring.
When it just became expected.
Right. When electricity stopped being a magic trick and started being this, invisible current running behind the walls, quietly powering the hospitals, the stock markets, the communication grids.
And that is exactly where we are with AI right now.
Welcome to today's deep dive. Today, AI has officially stopped being a glowing light bulb.
Yeah, we've definitely hit that tipping point. I mean, the era of being amazed that an algorithm can, just string together a coherent sentence,
Yeah.
that is entirely in the rearview mirror.
We're looking at a curated digest of technology updates today, specifically from June 11th, 2026. And our mission for this deep dive is to look at exactly how this shift is playing out in the real world.
Because it's moving fast.
It really is. We're examining how artificial intelligence is maturing from this general purpose novelty into a highly specialized, completely invisible infrastructure.
Right, the stuff behind the drywall.
Exactly. We're going to see how four specific sectors, ranging from your personal stock portfolio to your doctor's office, have quietly been hardwired to algorithms that basically know what is going to happen before you do.
And if you look at the underlying theme across all the sources in this digest, it's this massive leap in synthesis and precision.
Synthesis and precision. Unpack that a little.
Well, the sheer volume of data being crunched right now is staggering.
Okay.
But it's the application that matters now. These systems are moving past just generating text and into the realm of hyper-specific prediction and really immense risk management.
Right. But I feel like we have to start with the engine block, right? Before we can talk about the specialized applications in hospitals or high finance, we really have to look at the raw compute power that's making all of this possible.
You have to understand the engine, yes.
So the digest kicks off with OpenAI unveiling GPT-4.5.
The foundational layer.
Right. And, looking at the specs they released, the leaps in context understanding and natural generation are impressive, but that's not really the headline, is it?
Not at all. I mean, it generates more human-like responses, sure. But the actual headline, the thing that changes the entire macro environment, is the phrase, reduced computation costs.
Let's get into the mechanics of that, because usually, when we talk about a tech upgrade, it's just, hey, it's faster, it's smarter, it's bigger.
Right, this standard marketing pitch.
Yeah, but for a tech-savvy audience, reducing compute costs on a model of this size, it isn't just about shaving a few pennies off a server bill somewhere.
No, it completely changes who gets to play in the sandbox. It actually changes the physics of the software industry.
How so?
Well, up until recently, the approach to building these massive models was largely brute force. Just throwing thousands of ultra-expensive GPUs at mountains of data.
Which costs an absolute fortune.
Exactly. It was a billionaire's game. What GPT 4.5 represents is a shift toward algorithmic elegance. They've found ways to achieve higher cognitive output using just a fraction of the processing power.
So the democratization of access isn't just a buzzword here, it's an actual economic shift.
Far from a buzzword.
Right.
When the computational overhead drops this drastically, you're suddenly handing developers in emerging markets the exact same baseline cognitive toolkit that, heavily funded Silicon Valley startups have.
Wow.
I mean, think about it. A solo developer in Nairobi or Jakarta can now build a hyperlocal, highly complex tool without needing millions in venture capital just to cover their compute costs.
That's huge. But wait, I want to stick on a specific detail the source mentions. It says GPT 4.5 specifically learns user preferences over time. If this is becoming the invisible infrastructure for global business, like the engine block for developers, what does learning preferences actually look like at an enterprise scale?
It's a great question.
Because my mind immediately goes to, like, a consumer assistant. A chatbot that just remembers I like my coffee black or that I hate early morning meetings. Is there a risk of it just becoming an echo chamber of my own biases?
Well, that consumer application is really just the surface level. At the enterprise level, learning preferences means the model basically acts as a cognitive clone of a specific business logic.
A cognitive Okay, give me an example of that.
Sure. Imagine a massive logistics company using this to route shipping containers globally. The AI doesn't just calculate the mathematically fastest route.
Right, because any basic algorithm can do that.
Exactly. Instead, it learns that this specific company prefers to optimize for fuel efficiency over speed on Tuesdays. Or maybe that they have an unspoken preference for avoiding certain ports during specific weather conditions based on past decisions.
Oh, wow. So it internalizes the company's vibe, almost.
Yeah, it internalizes the implicit operational DNA of the user.
Which is fascinating, but also, and this brings up the other major update in the release, it highlights the need for enhanced safety protocols and operational transparency.
Absolutely essential.
Because if you are baking your implicit operational DNA into an algorithm, you absolutely need to know exactly how it is making its decisions, right?
Right. That transparency is basically the building code for this new utility.
Yeah.
You simply cannot deploy an opaque, unpredictable system into highly regulated environments, like education or healthcare.
And the digest highlights this specifically.
Yeah, the enhanced safety protocols aren't just about preventing the AI from, seeing something inappropriate on a customer service chat. They are enterprise-grade reliability metrics.
So it's less about PR and more about liability.
Exactly. It's the equivalent of getting a safety certification for a commercial elevator. You need to know the cables won't snap under pressure before you install it in a 50-story skyscraper.
Which is the perfect bridge, really, because we've sort of solved the hardware cost of intelligence and we have the enterprise reliability. But pure generalized intelligence isn't enough when human biology is on the line.
No, the stakes are entirely different there.
Right. When you take this incredibly cheap, reliable, raw computation and apply it to something like a tumor, the required margin of error basically goes to zero. And MIT realized this, which brings us to our next source.
This is where we see that raw infrastructure applied to arguably the most complex system on Earth, the human body.
So the digest reports that researchers at MIT have developed this highly specialized AI tool called OncoAI for cancer diagnosis.
Right.
It's using deep learning algorithms to analyze complex tumor data, and the early trials show it can predict treatment outcomes with remarkable accuracy. The ultimate goal here is guiding personalized medicine.
To really understand the breakthrough here, you have to look at what OncoAI is actually analyzing. Historically, a biopsy gives you a somewhat static snapshot of a tumor. But a tumor isn't just a solid block of uniform bad cells. It's a highly complex, dynamic microenvironment.
Right, it's an ecosystem.
Exactly. It's a living ecosystem. You have genetic mutations, structural changes, and literally millions of cells constantly communicating with each other and with the patient's immune system.
All at the same time.
Yes. The data density is just beyond human cognitive capacity to synthesize simultaneously. So OncoAI is utilizing techniques like spatial transcriptomics to actually read the chemical chatter between those cells.
Okay, let me try to visualize that. Imagine the tumor is a hostile military base, right? And it's transmitting encrypted radio signals.
I like that.
A human doctor, even a brilliant oncologist, looks at a standard scan and basically just hears static. They can see the size of the base, they know it's there, but they can't understand the internal communications.
Right, they can't read the encryption.
But OncoAI acts like a biological code breaker. It realizes the static is actually a highly structured language, which allows us to literally read the tumor's playbook before it makes its next move.
That is a phenomenal way to look at it. It's decoding the biological playbook. And because it can read that playbook, it fundamentally shifts oncology from a reactive posture to a predictive one.
Walk us through the mechanics of that shift. Like, practically speaking, what does reactive oncology look like today versus predictive oncology with OncoAI?
Well, much of standard oncology today, unfortunately, involves an educated trial and error process.
Right.
A patient is diagnosed, and they are put on the first line, standard of care chemotherapy.
Yeah.
You wait a few months, you take another scan, and you see if the tumor shrank.
And if it didn't?
If it didn't, it means the tumor has built resistance, and you pivot to a second-line treatment. But in that process, the patient has lost precious time.
Not to mention the physical toll of taking an ineffective toxic drug.
Which is devastating. But with OncoAI, because it's reading that cellular chatter we talked about, it can identify micropatterns indicating that this specific tumor already possesses the mechanisms to resist that first-line chemotherapy.
Oh, wow.
Yeah, it predicts the failure of the treatment before the patient takes a single pill. So it literally buys the patient time by routing them directly to the treatment that will actually work.
Okay, but let's play this out in a real clinical setting, all right?
Yeah.
The source explicitly mentions remarkable accuracy in predicting these outcomes.
Yes, it does.
If the AI becomes that accurate, if the code breaker is always right, what happens to the oncologist?
Well, they don't go away. if that's what you mean.
But if OncoAI says protocol A will fail, use protocol B, at what point does the human doctor just become a rubber stamp for the algorithm?
I'd argue the role of the oncologist actually elevates. They move from being a tactician to being a grand strategist.
So,
The algorithm can perfectly predict the chemical interaction between the drug and the tumor, right?
well,
But the algorithm does not understand the human being sitting in the exam room.
like the algorithm doesn't know the patient is an 80-year-old who just wants to be healthy enough to attend their granddaughter's wedding in 3 months.
Precisely.
Mm-hmm.
The AI provides a perfect map of the biological battlefield,
Mm-hmm.
but the human physician still has to weigh the patient's quality of life, their personal wishes, and their overall physical resilience.
Right.
The algorithmic precision augments the physician's deeply human judgment. It doesn't replace it.
That makes a lot of sense. So we are mapping the intricate networks of human biology to secure literal survival.
Hmm.
But the digest shows this exact same underlying technology, this massive pattern recognition being applied to a completely different type of network.
Right. Shifting gears a bit.
Yeah. Google is using it to decode human communication. We're moving from the literal fight for survival to the quality of daily human experience and really participation in society.
And this taps into a critical piece of infrastructure, personal accessibility.
According to the source, Google has rolled out this suite of AI-driven accessibility tools targeted specifically at users with disabilities. We're talking about major enhancements to voice recognition software and real-time translation services.
Specifically aimed at helping people with hearing and speech impairments navigate digital spaces.
Exactly, highlighting the tech industry's push for a more inclusive environment.
But the technological hurdle they are clearing here is latency. I mean, the term real-time is easily the most important part of this update.
Unpack that latency issue for us because, we all use voice to text on our phones to send a quick message, and it seems pretty fast. Why is this such a breakthrough?
Well, for standard consumer use, a half-second delay while the cloud processes your voice command is fine. You don't really notice it.
Right.
But in a fluid human conversation, a half-second or 1-second delay is an absolute eternity.
That's true. It throws the whole rhythm off.
Exactly. If someone has a severe speech impairment, traditional assistive software struggles. It often has to send the audio to a remote server, process it through a generic language model, and then send back a synthesized voice or text.
And that friction just completely breaks the conversational flow.
Inevitably. What happens is people end up talking over them.
Yeah.
They get left out of the fast-paced dynamic of a Zoom meeting or like a rapid-fire brainstorm. And the exclusion doesn't happen because of malicious intent. It happens purely because of latency.
So how does Google's new tool fix the latency?
What Google is doing is leveraging those highly efficient models we talked about earlier, like the GPT-4.5 architecture, and running neural audio compression directly on the device.
Oh, I see. Processing on the edge, not in the cloud.
Exactly. Processing on the edge. The AI is learning the unique phonetic patterns of the individual user's speech impairment and translating it into fluid synthesized speech or text instantaneously. Zero latency.
Wait, so this is basically an invisible ramp.
An invisible ramp.
Yeah, think about the physical world. A building without a wheelchair ramp physically locked a segment of the population out of the economy. You couldn't get into the bank, you couldn't get into the office. The physical ramp solved that.
Oh, I see where you're going.
This zero latency translation acts as a universal, real-time digital ramp. It takes different methods of human communication and normalizes them instantly into a seamless digital flow.
That's a great analogy. It changes the baseline architecture of the internet. For decades, assistive technology was a highly specialized, expensive, third-party add-on.
It was clunky.
Very clunky and siloed. By baking this level of neural processing directly into the core operating systems and baseline communication platforms, tech companies are fundamentally redefining who gets to participate in the digital economy.
Because the barrier to entry just completely vanishes.
It becomes a non-issue. You don't need a specialized app. The ecosystem simply understands you, regardless of how you vocalize. It brings an entire demographic of talent and perspective directly into the center of the economic fold.
The technology bridges the gap so silently that you forget the gap ever existed.
And that is the ultimate goal of infrastructure.
Yeah.
Right? You don't think about the plumbing when you turn on the tap.
Exactly. So we've seen this AI empower the individual developers getting cheap compute, doctors mapping tumors, and individuals communicating without friction. But the final piece of today's digest scales this up to an institutional, global level.
The macro crunch.
Right. What happens when you take this exact same zero latency pattern recognition and point it at the global macroeconomic system?
You get the ultimate stress test of synthesis and precision, because global finance is arguably the most complex, noisy, and volatile data set generated by human activity.
Well, the source reports that Goldman Sachs has fully integrated a sophisticated AI system into its trading operations, and the stated goal is optimizing investment decisions and risk management by analyzing these vast data sets to spot opportunities and threats.
Which is a massive undertaking.
Now, I have to be honest here. As someone whose retail stock portfolio is largely based on, pure vibes and whatever I read in the news that morning, the idea of an institution like Goldman having an AI brain is a little terrifying.
It's a paradigm shift, definitely. If you look at traditional financial modeling, even at the institutional level, it's highly siloed.
Like different departments not talking?
Sort of. You have an analyst covering the shipping sector, another covering South American regulatory law, and another looking at agricultural yields. They try to talk to each other, but they are limited by human bandwidth.
Right. They are basically forecasting the weather by looking out their respective windows and comparing notes. Like, looks cloudy over here. Well, it's raining over here.
That's exactly what it is. But what Goldman is deploying sounds like having a dedicated satellite network tracking every single molecule of air in the atmosphere simultaneously.
And finding the hidden correlations between those molecules.
Yes. And the source emphasizes investment decisions and de-risk management. In high finance, risk management is where this technology truly flexes.
Because it sees the storms coming.
Right. This AI isn't just looking for a stock that's undervalued by 2 cents so it can execute a high-frequency trade. It's looking for systemic, cascading, macro threats.
Give me an example of that. Like, what kind of hidden correlation would it spot that a human team would just miss?
Okay, imagine a scenario where there is a minor, localized drought in Taiwan.
Okay.
A human analyst notes that it might slightly affect local agriculture, but the AI ingests that data and correlates it with the fact that semiconductor manufacturing requires massive amounts of ultra-pure water.
Oh, wow.
It then cross-references that with current shipping bottlenecks in the Suez Canal and, say, a pending regulatory change regarding lithium mining in South America.
It strings all those disparate threads together.
It realizes that the combination of those three seemingly unrelated events will cause a catastrophic supply chain failure, like for European automakers 6 months down the line.
6 months out. That's wild.
Yeah. A human analyst could spend a lifetime in spreadsheets and never connect those specific, isolated data points across 3 different industries and continents. The AI spots the pattern in milliseconds.
But if it's that good, here's my question. Eventually, Morgan Stanley gets an AI like this, right?
Of course.
JP Morgan builds one. Hedge funds spin up their own versions using that cheap GPT-4.5 compute power we start the show with.
Oh, absolutely.
So if every major player has a satellite network perfectly tracking the global weather, doesn't the competitive advantage just completely evaporate? Does it just make the markets infinitely faster and more volatile?
It definitely neutralizes the advantage of pure information gathering. The edge is no longer about who has the data. Everybody has the data, and everybody's AI can spot the pattern.
So what is the job of a financial analyst in 2026?
The nature of finance shifts entirely. The human analysts are no longer number crunchers. They don't build financial models anymore. They become pure strategists.
Strategy over calculation.
Exactly. The AI hands them the macro insight. It says, European automakers will face a critical shortage in Q3. The human's job is to decide the most creative, asymmetrical way to position the firm's capital based on that absolute truth.
So the AI manages the mathematical risk, and the human manages the strategic execution?
Yes, it's the exact same dynamic as the oncologist in OncoAI.
Wow, you're right.
The AI maps the battlefield, and the human decides how to wage the campaign.
Let's bring all of these threads together, because what we've walked through today is basically a roadmap of our immediate reality.
It is.
We started with OpenAI's GPT-4.5, which took massive computational power, made it highly efficient, and turned intelligence into an affordable utility for developers worldwide.
And that underlying utility was then applied to specific domains.
Right. We saw it applied to biology, where MIT's OncoAI decodes the hidden cellular communications of tumors to predict life-saving treatments before a patient wastes time on the wrong drug.
Truly life-saving stuff.
And we saw it applied to human connection, with Google using neural edge computing to eliminate latency and build invisible digital ramps for seamless communication.
Redefining participation.
Exactly. And finally, we saw it scaled to the global economy, with Goldman Sachs synthesizing millions of uncorrelated data points to manage the chaotic risk of global markets.
It is the complete transition from a novelty to an invisible foundational infrastructure.
And the relevance to you listening right now is absolute. You don't have to be a tech developer or a hedge fund manager to feel the tectonic plates shifting here.
No, it affects everyone.
Whether you are managing your retirement funds or seeking medical care for a loved one or simply interacting in an online workspace, these unseen algorithms are fundamentally rewiring the rules of engagement for your daily life. They really are the new electricity, humming quietly behind the drywall of our society, ensuring the lights stay on.
That's a great way to put it.
But as we wrap up, I want to leave you with something to chew on. Something that wasn't explicitly written in any of these source updates, but is the undeniable shadow of everything we've discussed today.
Okay.
We have learned today that artificial intelligence has mastered the art of prediction. It is an unparalleled prediction machine. It predicts the code you want to write. It predicts the chemotherapy that will fail. It predicts the syllables someone is trying to speak. And it predicts the collapse of a supply chain 6 months in advance.
It's optimizing everything.
It is perfectly optimizing our world to eliminate friction and eliminate risk. But here is the question. As this invisible infrastructure seamlessly anticipates all of our needs and perfectly manages all of our risks, at what point does our reliance on its perfect predictions start to quietly erode our own human intuition?
Oh, that's heavy.
I mean, think about it. If we never have to guess the right treatment, if we never have to struggle to be understood, if we never have to take a blind financial leap based purely on a gut feeling, what happens to our human tolerance for uncertainty?
Because uncertainty is a part of life.
Exactly. Uncertainty is where discovery happens. It's where resilience is built. If the machine never lets us fail, what happens to the human condition when the invisible current is so perfect that the lights never, ever go out?
Wow.
Something to think about. Thanks for joining us on today's Deep Dive.